Okay, let's go ahead. And so we did talk about research projects in general, what kind of study designs there are. I think all of those can be applicable to orthopedics and also the statistics. As I said, we can talk this afternoon. I already talked to a colleague of yours during coffee break for certain problems or statistical analyses. If you have questions, we can talk also either over lunch or during the afternoon. Now, before lunch, and perhaps even afterwards, no, probably we stopped that before lunch, we will talk about research planning, how to conduct a research project. Okay, this was very important, and it's not easy, but it is easier if you follow certain principles. So we are going to talk about that before lunchtime. My question is, who is conducting right now a research project by him or herself? 1, 2, just 2? Who is involved in a research project? 1 and 2. And who is not involved at all in a research project and is not interested in research at all? Okay, so now who plans, the real question is, who plans to be involved in a research project? So most of you, right? Okay. Okay, so that's what we are going to do. And as I said, you can ask me during lunchtime or afterwards in the afternoon questions. I'm around. Okay, so there are 3 steps when we start thinking of a research project, how to conduct, how to implement it. First of all is planning. Second is the implementation, and third is obviously how to finish it successfully. All of these 3 steps have something in common. They need to be planned in written form. Planning needs to be written. It's nice if we can talk a little bit, but talking remains talking. It needs to be written because we need to verify what we said last week or 1 month ago. For example, I give you a good example. I've got an example of a recent PhD student of mine and a master student. I talked with the master student and the PhD student last week, and designed, for the PhD student is we work of a certain brain chemistry and use certain methods for that. And the master student said to me, "But hold on, I was actually meant to do that." And so I had to flip back to my documentation, and she was absolutely right. So it needs to be written in order to know what you planned before, and you need always to communicate. Now, this is what it is. 3 steps are extremely important for all of us, the principal investigator and everybody that is concerned and involved in the research project. Is communication, communication, and communication. The planning, implementation, and finishing, it always needs to be steadily communicated in written form. Okay? So, first, planning of the research project. Before you start anything, and before you have an objective, which scientific question needs to be raised, for example, before you come up with that, what do you need to do? What do we need to do before we come up with a scientific objective, a goal? State of art? What do we know? Absolutely right. So, where do we get the knowledge of what we know, what we should know? We read. What do we read? Where do we find papers? Where do we find these journals, these papers? Has everybody access to PubMed? Who does not have access to PubMed? Cool. It's a burden off my shoulders. So you know how to look for that, you know how to search for papers and so on. Okay. So what do you do if, for example, you're interested in bone marrow diseases? Okay, treatment of bone marrow cancer, for example. What do you do? What's the first step you're going to do? You type in keywords. And what happens then?
The titles are...
You see a title.
The names?
Name, the title.
The abstract.
The abstract. Okay, and what happens then?
I choose something.
You do something, you choose something. Okay, what do you do when you choose? You click on it, and what do you do then?
I read the abstract, and if it's really interesting, I read the paper. If not, I stay with the abstract.
Okay. Who agrees with that? Who does the same thing? Let's say it this way. Let's be honest. Who does the same thing? Okay. So almost everybody. Who does something completely different?
I look for some meta-analysis as well.
Yeah.
You look for
Just
reviews.
review.
Review paper. Okay.
You have like general view on the topic and then...
All right. How do you find the paper of Do you start at page 50 to read the book? Do you skip the conclusion? Do you read it from page 1 to page? You read the text from
the text behind
and
it.
everything. Wow. So when you read a book, you read everything. But if you read the research paper, you say, you skip maybe the introduction, you read the abstract, and if it's boring, then you do the next one. Okay? This is the introduction of any paper. The introduction of every paper needs, and I always call it funnel. Okay? You throw into this funnel whatever you have, and then if you skim it down to the nitty-gritty details of the scientific voids problems. Okay? And these, the logics need to be understood by every reader, no matter whether it's you, or you. Okay? No matter where you are, which field you're from, it needs to be logically constructed. And now we come to the problem. Okay, there is a problem in science that we need to solve because other studies have not done so for many reasons. And you identify these reasons, and these reasons are the basis of your research study. Okay? So, and then we are at the objective. This should be objective. This was very late yesterday. I couldn't write anymore. Okay, so this should be objective. Objective, which scientific questions or question needs to be raised? Okay? Now, what is the current knowledge in the field? Only research papers are the basis of scientific research. No newspapers, no reports, no notes, no coffee chats that you had last night with your colleague in the cafeteria. They all need to be based on scientific papers that are peer-reviewed. And something else. What is new about your research? So it's not confirmatory. It's explanatory. We sat during the coffee break, we talked about, how things were involved. There is a difference, but do we understand this difference? I'm not saying that we don't understand, but do we understand the difference? And what's the implication of understanding a process? Wow, maybe this can be applicable for many other things in medicine as well. So, objective, background based, and asking what's the novelty of my research question. Now, if we have that, what comes after the objective quite often? And hypotheses. So, what kind of hypotheses do we want to test? What's an hypothesis?
It's a claim that hasn't been proven with something.
What do you expect?
So what we expect, how we think the system works when we apply methods that we suggest. So, methods. What kind of methods are required? I'm sorry, there's some German sometimes in there. It was really very late last night, so I had to translate a little bit from German into English, because I gave it last time, I gave it in German. Methods. So what kind of methods are required to properly answer the questions? Extremely important. Especially in your field, what kind of methods do we need to apply, and are the methods that we choose required and the proper methods to solve the research questions that we set in the beginning? And scientific outcome, what kind of scientific results outcome can be expected from my research? Okay, once we have written that, we need substance to it. Substance includes people, includes time, and includes money. Okay? So how, where, with whom are we going to conduct this research? How much money, how much resources, where do the resources come from? Do we need to perform this research successfully? That also needs to be written down, okay? And normally when we do this, whenever it comes to money, we have a problem. Because money doesn't grow in trees. Even live in Switzerland. I don't know if anybody from Switzerland is here, but in Switzerland you can doesn't run freeze. Doesn't. So it's scarce. So this rare commodity needs to be overcome. So where do we get the money from? Where do you normally get, for those that do conduct research, where does the money come from? From the heart?
From our institutions.
From institutions.
The university, the hospital, whatever.
So the university has money. Your university has money.
No, not much.
Yeah. Yeah. Normally there is science foundations. In the States they had a National Science Foundation for healthcare, for health research. I know in Austria, for example, there isn't such a thing, but there's the Austrian Science Fund. In Germany, there's the German Science Fund. In Switzerland, there's something else. In Italy, there's something else, and so on. So there, the European Science Foundation, ESF. So this is all based on basic research. So if you've got basic research questions, we address these to these funding opportunities. Okay. So that means that we need to apply for that. We need to apply for this money, and it's highly competitive. But your chances increase if you follow these steps here. Obviously, there is also this gray science. I call it gray science when you get supported by pharmaceutical companies and so on. It's not per se a bad thing, but it is prone to some problems. But if you get the chance to apply for research, I give you an example. The basic research here in Austria is this Austrian Science Foundation called FWF. And what is important there, as the case in the European Union or in any other country, at the websites of these science foundations, you see how you can apply. Okay. Not only do you see how you can apply, you can also see what kind of research has been done already there and what kind of research has been funded. Okay. For example, yeah, I just used this Austrian website here, which is also applicable in English, available in English. And what you can do here is, for example, orthopedics, FWF. You look for orthopedics, then you've got a project finder. There's a guy called Bishop, okay? And he's not a bishop, but his name is Bishop. And they got a project called FAME. It's a fully automated MRI method in younger people. And you can look that up, and you can look at the abstract and the methods and so on. And then you can see if, for example, the Science Foundation in your country or at the European Union is able to fund your research, okay, if it's fundamental. If this is not the case, then you go to some other funding opportunities, which can be your hospital. Maybe your hospital has a research fund or an interest. Maybe there's money for that. There isn't a clear answer to where you can get research funding elsewhere, but the Ministry of Health in general has also funds, and there's also private funding, which is again different. You need to apply differently for private funds. Okay, so every project proposal needs to contain a scientific aim, it needs to be innovative, it needs to be hypothesis driven, it needs to contain clear methods with an expected outcome, a very good time plan and financial plan. This is for you now very important. We said, it's important the scientific aim must be clearly written and the methods must be very clear as well. But to be successful, if you get this research to conduct, you need to have a very clear time plan. This is just one plan that I read from an Austrian Science Fund project. Typically, when you do a pure scientific study, it starts with the literature research, and if you would like to get funding for the literature research during your project, you need to put that into the time schedule. Then, in that case, they have got a company research, then they've got a trip planned, and then they've got publications and symposium. Whatever the research plan is, it needs to be clearly written and justified. Justification, for example, here is start of the project, then we need to see what happens in the first year exactly, what needs to be done in the second year, what needs to be done in the third year. For example, here the end of the PhD project is in the third year, and you need to exactly write down what you do within these couple of years of this project. In addition to that, you need money. This is one of my own projects that I got down here. This the final sum of 432,000 euros for 3 years, and you need to write down what you need this money for, and absolutely clearly written so that you get the money and you know how to organize the money. Always include additional money, because you need to go to conferences, you need to publish your results. Publication fees can be extremely high today. They can rise up to 3,000 euros per paper. 3,000 euros per paper. That's a lot of money. And if you publish a lot, which we all would like to do, that means that every paper is a few thousand euros. So you need to have the money because you need to publish. Okay? That's important that you plan ahead of time publication costs. Now, here we said postdoctoral fellow or PhD student or chemical technical assistant. You get the money, you have the research, and you're working at a hospital, for example. You would like to get the data analyzed in at the station or at the hospital lab, for example, but you realize that the people Okay? So collaborators or students. Do they have the required or sufficient training? Yes, go ahead and do the research. If no, get the training. Allow them to be trained. Pay for the training. The same thing is true for PhD students. If you get, the worst thing is, because they cost a lot of money, PhD students, interns, cost a lot of money. And if you take on a PhD student, they cost in general about 120,000 euros, 15 years. It's a lot of money. And if it turns out that they're not good, it's a loss of money, it's a loss of time, but nobody benefits from that. So be very wise to know ahead of time with whom you're going to collaborate. And the same principle applies. If the people are good, but they're not well trained, train them. If the people are indifferent and you can't care less, don't bring them. Be very strict, be very clear. Because again, the result could be if you spend a lot of money that could be used differently, more wisely. Okay, same thing is for you. Are you sufficiently trained to conduct the research? The same principle applies. If yes, go ahead and do it. If no, you want to learn something else. You want to learn more. Go and get some more training. If you've got research money, do that. Go to different hospitals, go to universities, go to people that know better. Okay? Do it. Just do it. And again, at the end of the day, always remember, the patients will love you because you can treat them better. Okay? This is really important. That's actually why we do research. Get training. Something else. Is anybody affiliated to universities here? Anybody affiliated to universities, med schools? 1, 2. I think you're affiliated to med schools, right? You said before. Fantastic. If you can be affiliated to med schools, try to do that if you do a research project. Because in Europe, you can get lots of funding that is easily available for traveling. If you say in the UK, well, the UK is perhaps a better example today, but if you think that in France or in Spain or somewhere else, there is a group that you can learn from, you go there and the European Union can basically pay for it. Okay? Don't be shy. Use all of these resources for the benefit of science. Again, communication. Steady communication is key to success. I can't repeat that often enough. Please keep, throughout the research project, communicate with your colleagues, with your students, with the patients also, with everybody who is involved in a research project. Communicate. Now, I can talk, I draw back now for more than 20 years of my research now. Weekly meetings. Make it a habit that you sit down. I know you've got daily meetings at the hospital, okay, but you don't talk about research. But what you do on a daily meeting is how to conduct, how to treat the patients and how to organize the stations and so on. And the same thing is true for the research in meetings for research. Schedule weekly meetings. Encourage the people to write reports and make notes of what they did, because that's the only way that you can evaluate the progress. Monthly meetings should be done to set milestones, verify the research progress. It should also give you a possibility to see how you should modify certain things, because after a month you see if something works or if something didn't work. Again, if you did an experiment and after the experiment you find that nothing worked, it may have been better to verify in between the experiment if things go well or don't go well. So steady communication is absolutely important. For research projects in general, you need to write then reports anyway. So at the Austrian Science Fund, you need to write once a year a report. It's very unbureaucratic. I love it because it's only one page. One page, and you write basically what the progress is, and you write the publications and so on and so forth. And this gives you also a way of knowing where you are in the project. Okay, what we are going then to do in the afternoon is we discuss 3 papers, and I heard that all of you got the 3 papers that I sent yesterday. You didn't. Then you may want to ask to the lady that was sitting behind you. Or if you know, maybe you can communicate, because I don't have your emails, but people that have your emails, maybe they can send you the 3 papers. I know that, I think I know that you have been asked to bring your computer today, right? Did you do so? No? Okay. All right. Good. Because I would like to do in the afternoon, I would like to present again the research, how to read, how to write, and how to scrutinize existing research. And I picked one example in 3 papers. I picked the Achilles tendon rupture or problems, okay, and how people approached these problems in different papers and at different times, okay? So let's read these papers and discuss them with these 5 questions for the afternoon. What kind of research questions were raised in these papers? What were the aims of the research papers? What were the hypotheses? Were there any hypotheses? Was it missing? Is it necessary to put the hypotheses? Or let's see, okay, if these papers are still okay without raising or testing an hypothesis. Were the methods appropriate to answer the questions? And how did the authors analyze the data? This, we don't need to read all the paper, okay, I contradict myself now, but we have only an afternoon now, okay, we've got 3 papers. I sent these papers. Please, let's read them, either during the lunch break or afterwards, and to answer these questions, okay? Because during the coffee break, we talked about which journals we should look at. I looked at the SCI listed orthopedic journals yesterday, and obviously you can publish in Nature or Science or PNAS or anything else, or Nature Medicine, but they have higher impact factors. But these journals here are the best in orthopedics, and you know them. Journal of Bone and Joint Surgery, American volume, has the highest impact factor of all the journals that I found yesterday, with 5.28, and so on and so on. So, and we can carry on, and we see then that within 15 journals, we find still an impact factor of 2.5, which is okay. So these are the journals that, if you would like to present your research or submit your research, I personally always encourage my students to go for the best first and then drop down the ladder. Unless you don't care about that, which is okay, which is absolutely okay. If you just want to publish a note because your study, you know that your study is not up for the Nobel Prize, but you want to get it out to read by the people, okay, then you may go to something even lower than that. That's okay, it's absolutely fine. We are not competing in life, we want to contribute to science. So these are the 3 papers that we are going to read this afternoon. Achilles tendon rupture and abnormal lipid profile, a descriptive clinical laboratory and histology study from a lab in France. Then the efficacy and safety of corticosteroid injections and other injections for management of tendinopathy, a systematic review of randomized controlled trials. And then we've got the experimental rupture of the Achilles tendon in 1971. And again, these 3 papers with these 5 questions, okay? 5 questions, 3 papers. And let's read them. Let's discuss about how these papers responded to these questions. This afternoon, after lunch, we are going to, through guidelines, how to read and write research papers, okay? And I lifted already my first secret, because I stole your pen. Always use a pen when reading papers, and we are going to go after these, or through these guidelines after lunch. So, in the afternoon, I will talk a little bit, and you will read, and we discuss then these 5 questions. Okay?